Yeah, we're doing some more work. I think this is third session on this vision impairment simulator. We had two long sessions with GPT-4 and GitHub Copilot before. We have the structure of the project. So it's a Flask application. I'm just popping the current code. Shall we get it to do an overview? Should have been converting text to, what's it, speech to text, not text to speech. Okay, can you give a quick summary of this tool? We would like to publish it on our website. We are live streaming this, so if you have any funny comments, go for it. And we might need some improvement. Can we make sure that the default settings for the vision impairment simulate cover all cases and mainly go over the default current options? Yep. So you primarily have this JavaScript that does most of the heavy lifting. There is nothing in backend at the moment because I don't need your face for privacy reasons. The JavaScript applies the effects, so you have your blur, a brightness saturation, a contrast sensitivity, which could be also a vision impairment. I have this color saturation, doesn't do much. Wait, let's restart with default settings. Okay, if we remove the blur, the color saturation, there must be a template in the code, a placeholder. Sorry, not template, a placeholder. So it's actually not doing anything at the moment. So check for errors. Yeah, I've got a bunch of errors. Why? The length. Main.js 52. We don't have the data length. What is this length? Image data. This should be a quick fix. Let's do GitHub Copilot quickly. The image that is not correctly initialized. That should be alright because everything else works. Get this with peripheral vision loss and color saturation. And that's a bit odd. You need to ensure that the image data is correctly initialized and that it contains valid pixel data before apply effects. GitHub Copilot gave me potential fix. It's all the same. Okay, we have another if statement. It's actually checking if data is present or not. Let's try that. So get the same. Same error. Don't remember having this problem before. Let's go GitHub Copilot. Yes, it's built in Flask. Canvas element, yes. Yes, can be used for educational purposes. The default settings are somewhat arbitrary and may not effectively represent the average conditions in each impairment. Research-based default collaborate with ophthalmologists or use data from clinical studies. That would be good. I might add it into to-do list the bottom of the page. User testing. Yeah, that wouldn't work, would it? I wonder what it will. Can we go over the current default values? And yes, research-based default is great. Can you find data that could be used for this, for making the default values better? Now, user testing sounds great, but how would feedback from users with these conditions help? As in, okay, I think I understand. As in, patients describing what they see. Yeah, it will really matter if they have the condition from birth or not. So they might not be able to explain what they see because for them it's normal, isn't it? Yeah, can you expand on the guided tour stuff and how specifically can it be done? Could be nice, for example, if when you load the tool, potentially the sliders can be going left and right. For example, in order blur is 0 to max. Brightness is 0 to max and back. Now this one should stay in the middle. This one also default is a middle. Yeah, so initially when you load the page, currently it's displaying with a blurry, so potentially simulating myopia, hyperopia. That's okay. Still getting this two errors. I'm getting this error when changing the peripheral vision loss and color saturation sliders. How can we fix that? This is what I currently have as the whole JavaScript code. Yep. Let's see what we can do. It's also suggesting to fix the draw function, same as GitHub Copilot.
The error you're encountering, uncaught type error, cannot read properties of undefined reading length, is likely due to attempting to manipulate image data when image data might not be properly defined. This could happen if the context getImageData calls and retrieve valid data. Here's how you can modify your JavaScript to add more robust checking before processing image data.
Am I not already doing all that? Let's read the
You've raised an interesting point about how those with vision impairments perceive their condition as normal, and may not accurately describe what they see. However, feedback from these individuals is still invaluable for a few reasons.
I didn't say it was not valuable. I said it's sometimes hard to translate it into results. In this case, specifically adjusting the default values on the slider. So how do you link between the two?
Subjective experience. They can provide insights into the challenges they face in various lighting conditions or environments, which can help adjust the simulator's realism. Comparative feedback. By comparing the usual vision with the simulated effects, they can indicate whether the simulator overstates, understates, or accurately represents their vision.
I am still having a bunch of errors. One of them is, well, this is not an error, this is a warning, so might leave it for now. But then we do have the following error.
Comparative feedback. By comparing the usual vision with the simulated effects, they can indicate whether the simulator overstates, understates, or accurately represents their vision.
I was suggesting a guided tour feature.
A guided tour feature would help new users understand how to use the simulator effectively. Here's a detailed way to implement this. Interactive tutorial. Use a JavaScript library like intro.js to guide users through the interface. This can automatically highlight and describe each control as the user progresses.
Yeah, don't like using another library like intro.js. I think would be not necessary.
Dynamic examples. As each slider is introduced, automatically adjust it to show its effect on the vision simulation. For example, when the blur slider is explained, automatically slide it to a preset value and then back to demonstrate the effect of myopia.
That sounds more like it.
Similarly, adjust the brightness slider to simulate the glare effect of cataracts, then return it to a neutral position. Here's a simple example using pseudocode to guide a user through the blur adjustment.
Why is it a pseudo example? Why is it not the working code?
This approach not only makes the tool more interactive, but also educates users effectively by showing real-time changes as they learn about each function.
So we have the guided tour added to the code. This is what we currently have for the whole JavaScript. Another problem is that we are still having the following error. When changing the peripheral vision loss and color saturation sliders. Yep.
The error you're encountering, uncaught type error, cannot read properties of undefined reading length within the apply effects function when manipulating the image data suggests that it may be called in a state where image data is either not ready or incorrectly handled. Since this error specifically occurs when you're manipulating sliders for peripheral vision loss and color saturation, we need to ensure that the image data exists and is valid before it's accessed. If the error happens when adjusting sliders that directly affect the drawing logic, like apply effects, it could be that the video stream isn't ready or image data isn't captured correctly at the time of adjustment. Here's how you can add more checks before processing the data in apply effects. Also, ensure that the handlers for tunnel slider and saturation slider are properly invoking functions that expect valid image data. Here's an improved version.
I assume there's some there's more error handling. The draw function, let's try that. Apply effects. Yeah, we have that if image data is present. Then continue. Let's check it out. Okay, blur, it's working okay. Brightness, not available for effects application.
To create a simple guided tour without external libraries, you can leverage basic JavaScript and CSS to highlight elements and display instructions. Here's how you could implement it.
What is another function? Is it currently using some funny library? We need to call a guided tour in here, I would imagine. Just format the document. Yeah, it is using some intro JS, which I asked not to. It's not just deploy level simulating myopia. Okay, I thought it will actually move around. So no, I don't like it. Okay, what's that?
This simple function walks through each control element, highlighting it and displaying a message box with instructions. Adjustments can be made to fit more complex requirements or a more interactive user interface.
Yeah, I don't like it. Now I'm getting the following error. Interestingly, the peripheral vision loss slide that does work as expected. Color saturation doesn't do anything. And I don't get that error for any of the other controllers. I also removed the guided simulator because I don't like the way it works. I was more thinking down the line of when you load the page, it will just move some of the controllers left and right to see what effect they have, and then let the user control the application. Or even better, when they interfere and touch anything themselves, any of the controllers, then the control will pass on to the user. Yep. Forgot to add the code.
It seems like the key issue is that the effect applied by the color saturation slider isn't being reflected in the simulation, and you're also facing a challenge with the guided tour functionality. Let's address these points step by step. Firstly, if the color saturation slider is not affecting the visualization and no error is thrown for it, it might be due to how the effects are applied. In the JavaScript you shared, color saturation changes aren't being directly handled in the apply effects or any related function. Typically, color saturation isn't something that can be easily adjusted on a canvas directly through pixel manipulation like contrast or brightness. To simulate color saturation using CSS filters, a simpler approach, you can include it in your update canvas filters function. Here's how you can modify the function to include saturation.
Sure, I had this working before.
Ensure your saturation slider is correctly set up with appropriate min, max, and default values that correspond to reasonable saturation levels, e.g., min equals 0.5 inches, max equals 3, value equals 1. Regarding your idea for an automatic demonstration of slider effects upon page load, you can achieve this by setting up a sequence of adjustments that automatically run when the page loads, then stop as soon as the user interacts with any control. This script sets up an automatic demonstration of effects for each slider upon loading. It checks for user interaction to hand control over to the user, stopping the automatic adjustments. Adjust the time interval and step sizes as per your application needs to get a smooth demonstration.
That could be interesting. So we have this variable. Then we have an interaction listener that will check if the user is trying to do anything. We have an auto demonstrate function. And this can go at the end. Yeah, they're changing together, that's not great. It's a bit annoying. That function needs more work. It's a bit annoying. Uh, and then do the reverse. Demo index is not being used. With the demo when loading the application, we'll just like to scroll the blur all the way to its maximum value and then back to 0 if possible. Another problem is that when scrolling peripheral vision loss, the canvas is behaving as expected. However, I get the following error. How to fix? Yep. By the way, while it's generating, if you haven't checked biomedical.com, please go do so. You will be really helping the project out.
Let's tackle the issues you're facing one by one. First, we'll ensure that your demonstration effect for the blur slider works smoothly on load, and then we'll address the error occurring when adjusting the peripheral vision loss slider.
Fast.
The error, image data is not available for effects application, suggests that there's a point at which the apply effects function is trying to manipulate image data that either hasn't been correctly retrieved or is being accessed in an invalid state. To ensure you don't attempt to process invalid image data, you need to check its validity not just at the beginning of draw, but also right before applying effects in Apply Effects. Here's an improved check.
Is this warning related to the error we're getting? I don't think so. The errors are shown when moving peripheral vision loss and color saturation sliders.
The warning about multiple readback operations using get image data are faster with the will read frequently attribute set to true, can be addressed by setting the will read frequently attribute on the canvas context if your application frequently reads pixels from the canvas. This is especially useful if you're constantly getting image data in a loop or through frequent event handling. This attribute hints to the browser that the canvas will be used frequently for pixel manipulation, potentially optimizing its performance.
The demo in the beginning, well, in theory works okay, but then it's too quick to run. It's running before the image have been even loaded. The demo, when loading the page, is working okay. However, the blur slider starts moving before the video footage is even loaded.
This error occurs likely because the apply effects function is trying to manipulate image data when it is either not yet available or something has invalidated the image data contents. Given this happens when adjusting sliders that trigger apply effects, you might be running into race conditions or similar timing issues where the canvas hasn't been updated yet when apply effects tries to read from it. To mitigate this, ensure that any changes to the canvas from slider inputs wait until the video frame is ready and drawn before applying effects. Buffering changes. Rather than applying effects directly on slider input, you could buffer these changes and apply them once the frame is ready.
Okay, that sounds good.
Check video state. Ensure the video is in a ready state before attempting to draw and manipulate its data.
Okay, so in the draw function,
This additional error handling can prevent uncaught exceptions from propagating and potentially provide more detailed insight into what might be going wrong when the error occurs. Implementing these changes should help improve the robustness of your application and decrease the likelihood of encountering these performance issues and errors.
Was changed. We changed the draw function. This is the code that we currently have. The video footage isn't being displayed. How to fix? Yep. Well, we obviously can revert back to what we have, but I want the board to fix it itself and explain what's going on.
The issue you're facing where the blur slider starts moving before the video footage is displayed is likely due to the auto demonstration function starting immediately after the page loads, regardless of whether the video is ready to be displayed or not. To fix this, you should ensure that the video is playing and ready before starting the demo. This ensures that the demo only starts once the video has begun playing, which means the video data is ready to be manipulated and displayed.
Let's just rewrite the whole code. No, it did not. But shall we try it out? Because we don't mind simplifying the code. Currently it's 100 lines. I did regenerate the whole thing, didn't I? Oh, it's messing something up. There's no video footage.
This modification should help ensure that the demo only starts when the video is actually playing, thus making sure that there's video footage being displayed while the blur slider starts moving. This should address the issue of the demo starting prematurely before the video is ready.
We have no video footage. I want the board to fix it. We could obviously just revert back. But just trying to understand what's going on.
If the video footage is not showing up, the issue might be related to how the video and canvas are being handled or how the video is being drawn onto the canvas. Here are a few steps and checks you can take to troubleshoot and resolve the issue. Ensure the video element is set to play and that it doesn't have any attributes that might prevent it from displaying, like display, none, or being on a different Z-index layer hidden behind other content. You can also add video play inside your play event listener to explicitly start the video. The property video playing does not exist in the HTML media element API. You should instead check if video paused is false or if video ready state is sufficient to ensure the video is playing.
Yeah, we already have that. Check the canvas name. It's called canvas.
Make sure that the logic inside your draw function properly updates the canvas. Since you're applying a CSS filter, ensure that these updates are not being visually overridden by the CSS filter settings when debugging. You might want to comment out the filter application temporarily to see if the video itself is rendering without the filters.
Reverting back to the previous version of the code just fixes the video footage problem. It is displaying again with the following code. However, the following error is back. Let's try GitHub Copilot as well. Image could be the draw function is being called before the video starts playing. The video stream is not correctly set up. The canvas dimensions are not correctly set. No, I don't think it's getting the whole picture.
The error, image data is not available for effects app.
Yeah, that's still prefer the robotic voice then.
The error, image data is not available for effects application, indicates that the code is trying to access and manipulate image data when it's either not available or the canvas isn't ready. This typically happens if getImageData is called before the video is properly loaded or rendered onto the canvas. Since reverting to the previous version brought back the video display, but reintroduced this error, we need to carefully synchronize the video rendering and the image data manipulation. To ensure that image data operations only happen when the video is ready to be processed, adjust your draw function to better check the state of the video. Here's how you can do this. Check video readiness more robustly. Ensure the video is playing and has enough data to render frames before drawing or processing it. Error handling. Handle scenarios where the canvas or video isn't ready to avoid errors. Wait for video readiness. The code now waits until video ready state is at least 2. Have _current_ data, ensuring there is current video data available before trying to access the image data. Error handling. If an error occurs when trying to get or manipulate the image data, it logs the error and tries to draw again in the next frame. This can prevent the script from failing silently.
It's replacing this whole
This setup should help ensure that all operations related to video processing and image data manipulation are properly synchronized and that errors related to unavailable image data are handled gracefully.
errors. Okay, we'll be finishing in a sec. Go check out biomedical.com. You'll be helping the project. We'll be also adding some more blogs soon. Yes, even though they're generated with ChatGPT, it takes quite some time to get everything correctly, specifically the references. So we're just checking all of them before publishing. It will be on the limits of what you can do with EEG.
The error, image data is not available for effects application, continuously appearing suggests that the apply effects function is still attempting to manipulate the canvas image data where it may not be available or valid. This can happen for a few reasons, particularly around timing when the video frames are being read into the canvas. Verify canvas and video dimensions. Ensure that the canvas and video have the same dimensions and that these dimensions are properly set based on the video's properties. This needs to be checked because getImageData will fail if the canvas has not been sized or if it's trying to read outside its bounds. Confirm video playback. Before attempting to draw or manipulate the video's image data, make sure the video is playing. The checks should ideally be inside the draw function before you attempt to capture image data. Adjust request animation frame call. You may need to adjust when and how request animation frame is called to ensure it does not proceed to attempt to capture image data before the video is properly ready to render. Here's a revision of your draw function that incorporates better handling for readiness and a safety check for video play state. Double-check video size. Confirm that video width and video height are non-zero before setting them to canvas width and canvas height. Sometimes these values can be zero if the metadata is not fully loaded, leading to a zero-size canvas which will fail on getImageData. Logging for diagnostics. Add logging at critical points to verify sizes and readiness states. This helps to diagnose whether the video dimensions are being captured correctly and whether the video starts playing as expected. The above modifications should help stabilize the usage of getImageData by ensuring that all operations that depend on the video and canvas being ready are appropriately synchronized. If the problem persists, consider adding more detailed logging around each operation to trace the exact state of your application when it attempts to manipulate the image data.
Try zero shot prompt. Start a new chat. Just pop in the HTML and the JavaScript code. I also need the style CSS. Maybe that's what we forgot before. I think it does need to know that this is a Flask application. Everything works correctly, except I'm getting the following error when changing peripheral vision loss and the color saturation sliders. Yep. Well, so the color saturation doesn't actually do anything.
It looks like the error you're encountering occurs when you try to apply effects on the canvas, but the image data is either not valid or not available. This typically happens if you're attempting to process the data before it's fully available from the video stream, or if there's an issue with how data is accessed or manipulated in the apply effects function. To debug this issue, let's go over a few potential problems and solutions. Check video state. Ensure the video stream is actively playing and has data available when you try to get the image data. This might be failing intermittently due to timing or state issues with the video stream. Canvas context type you're using will read frequently, true, with the getContext method, which is optimized for frequent reading and writing, but ensure that your video and canvas dimensions are correctly set and consistent. Asynchronous data availability. There might be a race condition where apply effects is called before the video stream is ready to provide image data. This can happen if request animation frame, draw, triggers draw calls faster than the video can produce frames. Error handling. Improve error handling around accessing the image data. For instance, you could add checks to ensure image data is available and in the expected format before processing it. Logging for debugging. Add more console logging at critical points to understand if and when data becomes unavailable.
Thing is, the peripheral vision loss slider actually works as expected. It's still producing the error. The color saturation one is not working. Do we actually need to refract the code? This is what we currently have. Yep. Also, a suggestion from a GitHub Copilot catch stream. Okay, might have forgot to start playing the video here. Even though it does seem to play okay. State canvas filters.
It appears that the saturation effect isn't working because the saturate filter effect in the CSS filter isn't being applied properly due to the data type mismatch in the value you're setting for it. The saturate function in CSS expects a percentage or a factor, but the way it's currently being used in the JavaScript might be causing issues due to improper formatting or value handling. Ensure correct saturation value. The saturation value for CSS should be a factor where 1 is the normal level. If the slider returns a range between 0 and 2, then it should directly correspond to the saturate factor. However, it's crucial to ensure that this value is being correctly converted to a string and concatenated correctly in the CSS filter string. Refactor CSS filter application. The existing filter application method should be examined to make sure all values are concatenated correctly and are applied in a format that CSS can interpret. This function ensures that each filter value is appropriately formatted as a string with the correct units, px for blur, % for brightness and contrast, and no unit for saturation as its a factor, and then correctly applies them as a combined filter style to the canvas. Additionally, if the color saturation changes still don't appear to affect the displayed content, verify the following. Check the range inputs. Make sure the saturation slider is correctly set up in your HTML and is within accessible range. Debug output. Add console logs to update canvas filters to print out the values being set for the filters, especially for saturation, to ensure they're being updated as expected when the slider is moved.
Okay, nothing works. I like how it starts though. No, as in not nothing works. Blur works okay. When you start the page, it also does this demo thingy where it's just moving the blur up and down. So that's nice. Still getting... Yeah, color saturation doesn't do anything, and peripheral vision loss works okay, but I'm still, for both of them, getting this image data. Is not available. There's something wrong with the whole structure, something happening. Blur, brightness, contrast, we have update canvas, filters. Can you explain? Can you explain and fix the code primarily concerned with the fact that we have update canvas filters applied when blur, brightness, and contrast sensitivity are changed, but then we have apply effects when peripheral vision loss and color saturation are being moved, sliders being moved. Do we need to refactor the code considering these two functions meant to be similar? Is one of them changing CSS and the other one is actually applying something to the canvas? Can you explain and fix the code? Yep.
Update canvas filters function. This function is triggered when the blur, brightness, and contrast sliders are adjusted. It applies CSS filters directly to the canvas, which are handled by the browser and are purely cosmetic. These filters are fast and non-destructive to the underlying image data. Apply effects function, triggered by the tunnel, peripheral vision loss, and saturation sliders. This function is intended to manipulate the actual pixel data within the canvas. However, you mentioned that saturation isn't working as expected. The current implementation of the apply effects function doesn't handle saturation changes because pixel manipulation for color saturation isn't being done. Instead, it seems you're trying to use the CSS filter for saturation, which won't work with the current setup since CSS filters and direct pixel manipulation need different approaches. To resolve these issues, especially to make the saturation work as intended and to unify the approach, we could refactor the code to either apply all visual effects via CSS for consistency and speed where possible, handle all effects by manipulating pixel data directly if you need more control or non-standard effects that CSS cannot handle. Given your requirements, it seems like handling everything at the pixel data level might be necessary, especially for effects like peripheral vision loss and color saturation that aren't easily managed with CSS filters alone. Let's outline how you could adjust the saturation in the pixel data directly. Now, integrate this function into your existing apply effects. Ensure all changes trigger the necessary redraws and data manipulations.
Okay, just format this quickly. We need the apply effects. Why is it not a standalone?
Unified effects application. Make sure both types of effects, CSS filterable and pixel manipulation, are considered whenever any slider changes. You might find it cleaner to handle everything in one place if effects overlap or interact. Redrawing mechanism. Ensure draw is called anytime an effect needs to be updated, which it seems you're already doing. Optimization considerations. Handling all effects via pixel manipulation can be computationally intensive. If performance becomes an issue, consider debouncing the input events or applying effects only when changes exceed a certain threshold.
Yeah, we would be totally stuffing it up, wouldn't we? Okay, we need the better explanation. I'll provide the current code that we have again. I haven't made the previous changes yet. Now, one thing that isn't clear is why adjust saturation is called from apply effects. So we essentially have 5 effects. Do we need to handle each one separately? Yep. Yeah, it's getting tangled up in its own mess.
It looks like you want to ensure all effects are handled properly, whether through CSS filters for simple adjustments or through direct pixel manipulation for more complex effects like peripheral vision loss and color saturation. Given that, it might be beneficial to consolidate how effects are applied to streamline the code and ensure consistency. Unified effect handling. Instead of having separate handlers for CSS filter effects, update canvas filters, and more complex pixel manipulations, apply effects, instead of merging these operations into a single function. This will help in managing the effects in one place, making it easier to control the sequence of applying these effects and reducing potential conflicts or redundancies. Redefine apply effects to include all adjustments, since some effects like color saturation need pixel manipulation which isn't handled by CSS filters effectively in your context. You could redefine apply effects to handle all adjustments, including those currently handled by CSS filters. Directly on pixel data if performance allows. If performance becomes an issue, revert back to CSS filters for basic adjustments. Optimize performance. If this approach of manipulating all effects in pixel data is too performance intensive, consider keeping simple CSS filters for effects like blur, brightness, and contrast while using direct pixel manipulation for tunnel and saturation effects. You need to toggle between these approaches based on performance tests.
Yeah, I think we we are done here. We're talking cross-purpose, getting mixed up in our own, chasing our own tail kind of thing. So I get it that blur, brightness, contrast can be managed using CSS, adjusting CSS, that's fine. And then peripheral vision, it's actually changing the pixels on the canvas, which is fine. So that would be the more computationally intense operation. Now it still doesn't explain why color saturation doesn't work at all, and also doesn't explain why the apply effects function is giving an error. So this, of course, will not do anything.
This refactor aims to consolidate your effects into a single, manageable function, improving maintainability and potentially reducing bugs or unexpected behavior by handling all visual transformations consistently. Adjust the complexity and scope of direct pixel manipulation based on performance and visual requirements.
It is slower. Now blur doesn't work. It's significantly slow. Which we do not like. We do not like it. Yeah, so this three why color saturation can be done in CSS as well. Anyway, have to continue this next time. Don't forget to check out biomedical.com. There's a lot of interesting tools and blogs, and you will be helping the project this way. Don't forget to leave your comments, feedback. I will read it all. Might take some time, and we'll continue with this one next time. Bye.